Hi, welcome to Learning Monkey. I am Vikram. In this class, we will try to understand the time complexity of linear search and binary search. The detailed explanation about the linear search algorithm and the binary search algorithm has already been made in our data structures course. If you haven't watched that video, please watch those videos and come back here. And every video in our channel is going to be a part of entire course or a playlist. Our suggestion is to follow the entire course so that you can have better understanding of the concepts. Let's try to understand the time complexity of linear search and binary search. So this algorithm is for the linear search and this algorithm is for the binary search. So we have discussed that. So this for loop is going to iterate. So this algorithm, this for loop is going to iterate from 0 to n minus 1, means it is going to do all the comparisons, and whenever in each and every comparison we are going to compare the element to be searched with each and every element. If it happens to be true, then it is identified. If it does not happens to be true, means if it is not identified after the n number of comparisons, it is known that the element is not present in the array. So that is how the linear search works. Now, what is the best case for the linear search and what is the worst case for the linear search? So the best case is if the element to be searched is identified in the first comparison. For example, if you are trying to search for 2, where we are going to get the 2? So in the first comparison we are going to find that the efficiency is, we are going to find the element to be searched. In such case, so this is what we call it as the best case. So in such case the efficiency of the algorithm is 1. So it is going to take a constant amount of time. Every time if you are trying to search for the first element, it is going to take a constant amount of time, which is 1. Similarly, what is the worst case possibility? The worst case possibility is if the element to be searched is identified at the end of the array, means the last element of the array, it is going to take n number of comparisons. In worst case, we are going to do n number of comparisons. This for loop is going to iterate for n times. Okay, so if the so this is the worst case possibility. Okay, now what is the efficiency? What is the efficiency of this algorithm? The efficiency of this algorithm is big O of n. So why big O? Because the at most number of comparisons, as the input changes, so we are not sure that whether at what point we are going to get the result. So it may get in the middle, it may get in the first, or it may get at the last. But in worst case, in the worst case, it is going to take n number of comparisons. So that is the reason why we have taken the efficiency of the linear search as n, big O of n. And what about the efficiency of this binary search? The efficiency of the binary search is log n, and we will try to understand how it is going to be take log n number of comparisons. Here we are having 9 elements. So if you take log of n, it means that it is log of 9. As we are having 9 elements, log of 9 is nearly 2 power 3. So 2 power 3, it is in between 2 power 3 and 2 power 4, right? So the number of comparisons to identify the existence of the element in this array will be between 3 and 4. Okay, so hope you're getting that point. So log n means, so we'll try to expand this. So here we are having 9 elements. Now we can write this as 2 power 3 point something. Okay, 2 power 3 point something. And if you bring that, we will take it as, so for better understanding what we will do is, so we'll take only 8 elements. Okay, so it will be more easy for you to understand. So these points you may get confused. So we will take only 8 elements. So now here, as we are having 8 elements, if you apply log on it, it is 2 power 3. 2 power 3 means 3 comparisons. So within these 3 comparisons, we are going to find whether the element is existing or not. So how we are going to get the existence of the element within log n amount of time is, initially we are going to start with the mid element. So as the mid element is 5, now next we are going to compare that element with 5. If it is existing, then it is okay. So we have identified the element. If it is not existing, then we are going to take only the left part, because the element to be searched is less than the mid element. In that case, the mid, again we are going to find the mid element, and here in this case, so here one comparison is done. Try to get that. Here one comparison is done, and here another comparison is done. 2 is compared with 3. Is it true? No, it is not true. It is not true. So again we are going to find, because the element is on the element to be searched is greater than the element mid element, we are going to compare the right hand part of the array, means these two elements. So within these two elements, the mid element is here. So this is our mid element. Now 3 is compared with 3. So is it true? Yes, it is true. Now the number of comparisons done is 3. See here, first comparison, second comparison, and third comparison. Within these 3 comparisons, we are going to get the result whether the element is existing or not. So we may get the result in first comparison, that is the worst case possibility, or you may get the result in the middle second element, or you may get the result in the third element. If you are taking the next comparison, means the element is not existence, so not existing in the array. See, then the value of low will be greater than high. So if you again apply the mid value here, so it will be, so the mid value is going to be at this point, and 3 is greater than, so the low is going to be this and the high is going to be that. So 3 is greater than 2. So which represents that this is a false statement. So at most, so this binary search is going to take log n number of comparisons. So log n number of comparisons. For example, if you have 16 elements, at most it is going to take 4 comparisons to identify whether the element is existing in the array or not. See here. So that is why the binary search is more efficient when compared with linear search. But the rule is the elements to be in the sorted order. Okay. So this is the time complexity of linear sort and binary search. Linear search and binary search. Hope you got the clarity on this concept. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding this concept, please post your doubt in the comment section below. And if you feel that this video is helpful to you, please give us a like symbol and please share this video with your friends so that they will also get benefited. Thanks for watching.